This project was based in East Shoa, Ethiopia, in the Oromia region near the capital city of Addis Ababa. NASA Earth observation systems were used to determine the relationship between environmental factors and malaria cases.
And the project that we are developing within the NASA Develop program is to create an early warning system for forecasting the outbreaks of malaria in Ethiopia.
Approximately 3/4 of the country experiences malaria. Despite the fact that it is highly preventable and curable, it is still the area's leading cause of morbidity and mortality. Children under the age of 5 and pregnant mothers are particularly vulnerable. Both endemic and epidemic malaria occur in Ethiopia. People in endemic regions develop a tolerance to the parasite, and they are less likely to die from the symptoms. Highland and semi-arid regions, such as where East Shoa is located, are largely epidemic regions, as the disease is less common and immunity is poor or non-existent. When a person is bitten by an infected mosquito, the Plasmodium parasite, which causes malaria, enters the bloodstream and travels to the liver cells. They reproduce in the thousands in the liver before leaving to infect red blood cells, causing flu-like symptoms and possibly death. When a different mosquito bites an infected person, they take up the Plasmodium with the blood, and the parasite can then be transferred to a different human host. Temperature and precipitation are critical environmental factors to the transmission of malaria. Both the Plasmodium and the mosquito require warm temperatures for reproduction, and the mosquitoes also require stagnant pools of water in which to lay their eggs. Because Ethiopia is located in the tropics, cool temperatures are largely a function of elevation. It gets cooler the higher up into the mountains you go.
So for a long time it's been known that actually being in highland areas, particularly say in Africa, where malaria is particularly predominant, is a way of avoiding malaria. And many countries, in Ethiopia for instance, malaria control is very often limited to 2,000 meters, above which it's assumed that malaria is not a serious problem. And below is where malaria is increasingly endemic as you go down the slopes.
The malaria situation in Ethiopia is very diverse. It varies from village to village, from area to area. We would be very interested to have an early warning system where it can tell us with higher probability where would be the areas that would be affected by epidemics, and we could decide where to put our money, our resources.
An understanding of the environmental factors is crucial for developing a malaria early warning system.
We use the TRIM dataset for monitoring rainfall and to predict outbreaks of malaria. We also use temperature data based on Moody's land surface temperature during the night and during the day to have an estimation of the air temperature that will influence the transmission of malaria. We will use also the Moody's images for monitoring vegetation and water bodies. And finally, using Landsat images, we will look at more detail what are the water bodies and how that impact the breeding site for mosquitoes.
Time series of the data from NASA's Terra and TRIM satellites were extracted using the International Research Institute Data Library from the Lamont Doherty Earth Observatory. The data were analyzed at a monthly level and averaged over the 12 districts in East Shoa. These time series were compared with the time series of epidemiological data of malaria cases provided by our partner organization, the Center for National Health Development in Ethiopia. Elevation data from the Shuttle Radar Topography mission were used to map the elevation of the districts. When compared with the malaria cases, it was found that, contrary to prior beliefs, malaria cases were seen above 2,000 meters. Landsat data, compared between known flood and drought years, was used to determine how moisture was playing a role in the region. Vegetation was found even during drought years, often due to irrigation. Within the last 10 years, farmers have begun building dams to trap water past the rainy season, which can extend conditions conducive to malaria transmission. The information found, namely that temperatures can exceed the malaria threshold above 2,000 meters, and malaria in most districts followed heavy precipitation events, will allow for the development of a malaria early warning system in East Shoa. This information is very important in regard to climate change.
People have been concerned about climate change and malaria for quite some time. The idea is that since those mountains are now becoming warmer, the spatial distribution of malaria can also shift up the mountains. And it's been actually quite difficult to get the right information, the right climate information to show that there's warming in these highland regions that could actually be contributing to increases in malaria. Now I think we're very clear that the East African highlands, for instance, have been warming. Not everywhere, not exactly the same way everywhere, but consistently across the region. And it seems likely that malaria transmission will have responded to that warming.
Since malaria is a climate-sensitive disease, changes in climate variability are likely to result in epidemics.
We need to target our resources in areas with high malaria probability of malaria epidemics. So this early warning system would be very important in the prevention of malaria.
So the story is not over. There's still a lot more to be done.